Hi dear students, welcome back to e-session. Dear students, today topics are hydraulic and pneumatic motors which are in the module 2. This is my class 2, myself Santosh VJ. Let me continue the session. Dear students, as per the today topic, let us discuss the electrical actuators. Before dealing the electrical actuators, just have a look on general features of electrical actuators. These electrical actuators are easy to control. The ranges of these electrical actuators from microwatt to megawatt. Normally high velocity ranges from 1000 to 10,000 rpm. These electrical actuators have several types, and these electrical actuators have an accurate servo control, and these electrical actuators provide a accurate servo control and provide the ideal torque for driving. These electrical actuators have an excellent efficiency, and these have a autonomous power system difficult. Dear students, just look at the image. Here we have a different shape and sizes of the electrical actuators along with the different ranges. Let us discuss the introduction about the electrical actuators. Dear students, an electrical motor is an transducer and an actuator because it converts the electrical current into a large magnetic field and then turns a shaft, which means in mechanical energy. The electrical energy is converted into a mechanical energy by means of transducer. And electric motors are used an electromagnetic induction to generate a force on a rotational element called the rotor. The torque is required to rotate the rotor is created due to the interaction of magnetic fields operated by the rotor and the part surrounded it, which is fixed and called the rotor. Yes, here we have three different classifications or three different types of electrical actuators. Number one is a solenoid electric motors and stepping motors. And let us discuss the solenoid actuators, dear students, which are simple form of electromagnetic that consist of a wire bobbin of isolated copper or of another appropriate conductor, which is coiled in a spiral around the surface of a cylindrical body, generally with a transverse circular section. When the electrical current is sent across these wounds, they act as an electromagnet. The created magnetic field is the motive force used to open the valve. Hope you understand. Okay, dear students, have a look on this image. Dear students, this is the solenoid coil which is made up of copper material. A solenoid is a coil wound into a tightly packed helix. In physics, the term solenoid is refers to a long, thin loop of wire and warped around a metallic core, which produce the magnetic field when an electric current is passes through it. According to this statement, dear students, here we have two examples in a schematic. One is a current off, whereas other one is a current on. Dear students, according to this image, or which indicated that a solenoid coil is parted from the circuit, so there is no current passes through it, which means there is no magnetic field generated through the coil. Hope you understand. Whereas the second image is indicated that the solenoid coil is attached to the electric current. Now the current is passes through it and magnetic field is generated. So which means current on. Hope you, dear students, understand this. Now let us discuss the electrical motors. An electrical motor means the electromechanical device that converts the electrical energy into mechanical energy. The physical principle of all electrical motors is that when an electric current is passes through a conductor, usually a coil of wire, placed within the magnetic field, a force is exerted on the wire, causing it to move. Generally, the mechanical devices are run by the electrical motors, which are rotate pump impeller, fan, blower, drive compressor, lift materials, and motors in industry. Around about 70% of electrical load is used, especially mechanical industry. What electric motors do? Dear students, electric motors are used to operate the pumps, generators, compressors, fans, blowers, and other industrial equipments. Why they do it? Dear students, they convert the electrical energy into a mechanical energy. So the examples are industrial processes, agriculture equipments, and household uses. Let us discuss the electrical motors. Classification of electrical motors. The electrical motors are classified based on the currents. One is a alternating current, other one is a direct current. The alternating current generally we can call as a AC current, and direct current generally we can call it as a DC motors. Here in AC motors we have other sub categories or sub classifications or sub motors, which are synchronous motor, induction motor, single phase motors, and three phase motors. In a DC motors, which we have a separated excited and self-excited motors, series motors, compound motors, and shunt motors. Let us discuss the DC motors, dear students. Here we have a general features of DC motors, and also we have a image of DC motors. What we can see, this image is a typical application of a DC motor. The features of DC motors are simple and cheap, easy to control. The power ranges from 1 watt to 1 kilowatt, can be overloaded, brushless wear, limited overloading on high speeds. Asynchronous motors, dear students, the features of asynchronous motors. These motors are very simple and very popular in industry. These motors have a range from 0.5 kilowatt to 500 kilowatt. The more difficult to control the frequency. These asynchronous motors are more difficult to control the frequency. Nowadays, as accurate control as a DC motors. In these asynchronous motors are used in mobile machines also. Around about the capacity is 5 kilowatts. And synchronous motors, the general features of synchronous motors are usually a big range from 100 kilowatt to up to megawatt. These motors are also small ones, brushless DC motors from the range around about 50 watt to 100 kilowatt. These motors are controlled like as motors means frequency. The frequency will be controlled in these synchronous motors. These are used in ship applications and several industries and mobile machines. Let us discuss the stepper motors. Yes, dear students, the working principle of stepper motors. A stepper motor is an electromechanical device which converts the electrical pulses into a discrete mechanical movements. The shafts or spindle of a stepper motor rotates in discrete step increments when the electrical compound pulses are applied to it in the proper sequence. The motor's rotation has a several direct relationship to these applied input pulses. The sequence of the applied pulses is directly related to the direction of motor shaft rotation. The speed of the motor shaft rotation is directly related to the frequency of the input pulses, and the length of the rotation is directly related to the number of input pulses applied. Yes, general features of these stepper motors: angle control, slow process, usually no feedback are used, accurate positioning without feedback, not a servos, and easy to control. Yes, some other advantages of stepper motors: no feedback hardware is required, but in disadvantages, the no feedback is a drawback of these stepper motors, because often feedback is still required, because for precision reasons, since a stepper motor can lose a step signal. This is the reason. And other reason is requires 2 H bridges plus amplifiers instead of 1. And other reasons, driving software is different but not much more complicated, and some other controls, for example, support steppers motors in firmware. So these are the reasons the stepper motors are need to set the feedback system. Yes, these are the general applications of electrical motors. So as you can see the image, dear students, now let us discuss the applications of DC shunt motors. So here we list out the applications of DC shunt motors, which are lathes, lathe machines, vacuum cleaners, pressure blowers, constant head configuration pumps, compressors, reciprocating pumps, fans, wood making machines such as a circular saw, wood planers, laundry washing machines, and milling machines. And other applications: compressors, stamping machines, pressure blowers, variable head configuration pumps, door lifts, rotary presses, flat bed press, circular saws, metal planer, shearing machines, punch press, rolling mills, and freight elevators. Let us discuss the piezoelectric materials, dear students. Pierre and Jacques Curie discovered the piezoelectric effect in 1880. The application of an electric field to a piezoelectric crystal leads to a physical deformation of crystal. The piezoelectric materials are normally quartz, ceramics, lead zirconate, titanate, a kind of composite ceramic composite material. Advantage of piezoelectric actuators are the short response time, an ability to create a high forces, a high efficiency, and high mechanical durability. These advantages have a small strains, range around about 0.1 to 2%. High supply voltage needed for such kinds of piezoelectric actuators. Large hysteresis. For example, accurate actuators doesn't go back to exact where it started. That is the drawback of the piezoelectric actuators. And this is the construction of piezoelectric actuators, dear students. This is what we can see. This image is a detailed construction of the piezoelectric actuators. This is the rotor. This part is a rotor, and this is the starter. This below is this frame is called, below frame is called as a starter. That above is an rotor. This is the casing. This face is the casing. Sorry, these two are the coils. What we can indicate it in blue colors, these are the coils, and this is the internal image of the kind of motor, piezoelectric motor, uh, piezoelectric stepper motor, the internal component of the stepper motor. Dear students, this is the construction of stepper motor. So come back to the concept of the stepper motor. Dear students, this is the uh, constructional features of the stepper motor. What we have, this is the rotor part, and this is then a starter part. What we can indicate it, this is the blue color is a coils, and this is the internal part of a starter and rotor. This is the starter and this is the rotor. This is the internal image, and this is the external or outside casing, outside image of that stepper motor. Okay, dear student, let's come back to the piezoelectric construction and working. As we can see this image, dear students, this is the piezoelectric transducer. So let us discuss the working principle of piezoelectric transducer. Dear students, this is the force member, the force summing member. What we can say, this is the force summing member, and this is the voltage, output voltage, and this is the base, and this is the crystal. So this is the pressure port. Dear students, the figure shows a conventional piezoelectric transducer with a piezoelectric crystal inserted between a solid base and the force summing member, as we can see the image. If the force is applied on the pressure port, the same force will be applied on the force summing member. Thus the potential difference will be generated on the crystal due to its property. The voltage produced will be proportional to the magnitude of the applied force. Hope you understand, dear students. Let us configuration of the piezoelectric actuator. The piezoelectric ceramic crystal is coated with a silver on both the sides. The guide to a brass or nickel alloy or a stainless steel disc. If it is a brass, which is mainly a commercial and industrial purpose, not subjected to an environment. If it is a nickel coated, used where it is subjected to a environment. If it is a stainless steel, used where it is subjected to a solvent and a corrosive or chemical and underwater and medical fields. As types of the piezoelectric actuators, dear students, the piezoelectric stack actuators produce the linear motion, is a linear motor, and one piezoelectric bender actuator. What is this? A piezoelectric bender actuator. This is the stacking actuator which will produce the linear motion. So other types of the actuators, heaters used with the temperature sensors and temperature controllers to control the temperature in automated molding equipments and in soldering operations. Other actuators are lights. Lights are used in almost all machines to indicate the machine state and provide the feedback to the operator. So lights which are LED, LCDs, gas plasma display, and CRT. And other sirens or horns. Sirens and horns can be used for the unattended or dangerous machines to make the conditions well known. Okay, dear students, let us continue to discuss the hydraulic motors. The hydraulic motors, which is also called as a rotary actuators. The rotary actuators are also called as a hydraulic actuators. These are the large number of applications in the fluid power system where output motion is required in the form of a rotary motion. It may be a limited rotary motion of a few degree or continuous rotary motion. In such a cases, the rotary actuators can be used to give a rotary motion as an output. Hope you understand. Therefore, the rotary motion actuators can be broadly classified into a limited rotary type and continuous rotary type, as we can shown below the image. Now let us continue, dear students. Now we will discuss the continuous rotation type of hydraulic motors. In that we will discuss the van motors. Before that, we should understand what is exactly the continuous motion. The hydraulic motors are continuous rotary type of actuators. They provide the continuous rotation and develop the torque. Theoretically, it is exactly opposite of pump. That it is, any pump can be used as a motor. If reversed, a pump takes a mechanical power as an input and takes the oil at a low pressure and converts the oil into high pressure of oil. A motor makes the oil at a high pressure and sends out the oil at a low pressure and converts the fluid energy into mechanical energy at the motor shaft. Hope you understand. This is the continuous rotation. The hydraulic motor fluid is used for a wide variety of applications such as an hydrostatic transmission, conveyor belt systems, aircraft steering and control systems, anti-aircraft gun or missile and subsystems, antenna, radars, control system and gun turret control systems. Though any pump can be used as a motor, the commonly used hydraulic motors as follows. One is a van motors, other is a gear motor, and third one is a piston motors. Now let us discuss the working principle and general features of a van motor. Dear students, as we can see the image, this is the van motor. The van motor work on the principle of opposite to that of van pump. Hope you understand. The working principle is opposite to that of van pump. As shown in the figure, the student shows the working principle of the van motor. It consisting of a cylindrical rotor. This is the cylindrical rotor with a radial slots. With a radial slots, vans are inserted into these slots. The vans can slide freely inside the slots. This rotor is mounted inside a cylindrical casing but eccentric with the casing as shown in the figure. These bands can be moved out of the slots and remains pressed against the outer casing by any of one of the following method. This is known as a van loading. There are two types of van loading. That is one by applying the oil pressure at the center of the rotor so that the vans are pushed out of the slots. That these vans are pushed out of the slots. By other means is the springs are inserted inside the slots. The springs are inserted inside the slots so that the springs keep the vans pressed towards. Oil at the pressure enters the slots from the end plates, or end plates means end port plates, and kindly and kidney ports are similar to those of the piston pumps as shown in the figure. Though the kidney shaped ports to the slots through hole drilled in the rotor. This will pushes the vans towards and they press against the starter. The oil will enter the enclosed chamber between the vans and the starter and pushes the vans to rotate. When the rotor rotates, the vans makes the sliding contact with the casing. The oil is continuously expand also as the volume of the chamber is increases. During the rotation of the rotor, a van loading increases caused by the centrifugal force produced due to the rotation of the vans. The pressurized oil is supplied to the chamber in between two vans. When the pressurized oil expands due to increased volume, it applies a tangential force which develops the rotating torque on the rotors. Hope you understand. Now come to the gear type of motors. Dear students, as we can see the image, the gear motors are based on the principle of opposite to that of the gear pumps. The various types of gears motors are commonly used as a spur gear motors, helical gear motors and screw gear motors. The figure has shown in the image, dear students. This is the constructional features of the gear motors. It consisting of a two spur gear. It is a spur gear type. Spur gear connected as shown in the figure. So outlet gears and inner gear with their axes parallel to each other. One of the gear is connected to the output shaft and the other shaft is the ideal or idler. Oil at the pressure is supplied at the inlet. The high pressure oil expands and produces the rotational motion of the gear and produce the torque at the output shaft. Hope you understand. After expansion of the oil will move out of the low pressure from the exit side. Thus a continuous flow of oil is maintained and the motor shaft is continuous to rotate. Hope you understand. Yes, now let us discuss the piston type of motor. A piston type of motor, the piston air motors are used in, okay. Okay dear students, now we will discuss the piston type of motors. In that we have a two category. One is a radial piston type motors, other one is a axial piston type of motors. As you can see this image, this is then a 3D image of radial type piston motor. Let us now, okay, here dear students, the schematic diagram of a kind of radial piston motor. Figure shows is a constructional picture of radial piston motor. Dear students, now I will explain the arrangement of this radial piston motor. Here this portion is a inlet, and this is a piston rod, and this portion is a cylinder block, and here this portion is a cylinder. Dear students, in a radial piston motor, the pistons are arranged radially around the periphery of the cylinder block. Yes, the periphery of the cylinder block. The piston reciprocates radially outward and inward when the cylinder block rotates. Hope you understand. The pressurized oil is admitted into the cylinder through ports, and at the center of the cylinder block, the piston rod makes the contact with a concentric cylinder ring outside the cylinder block. Hope you understand. The pressurized oil enters the cylinder readily and expand thereby pushing their pistons outward. When the expansion is complete, the low pressure oil is removed from the opposite half of the cylinder block through the outlet. The reciprocation of the cylinder is converted into the rotational motion of the cylinder block, which develops the required torque on the shaft. So due to this reason, the oil will inlet and the pressurized oil will outlet from the outlet port. Hope you understand. Now coming to the, this is the schematic diagram of 3D schematic diagram of axial piston motor. Dear students, let us discuss the now let us discuss the axial type of piston motor. Dear students, as we can see, the image is on a schematic diagram of axial type of piston motor. So as shown in figure, this is the assembled view of inline piston motor, mainly which consisting is the inlet port or oil inlet. This is the oil exit, and this is the port plate. Dear students, this is the whole is a cylinder, and this portion is a, sorry, this portion is a this whole portion is a cylinder block. This is the cylinder, and this is the shoe plate, and this is the swash plate, and this is the outlet shaft. Okay, let me to clear how it works. It consists of number of cylinders arranged around the periphery of the cylinder block. Inside each of these cylinders, plungers or pistons can reciprocate. The high pressure oil enters from the outside into each of the cylinders. This oil expands, causes the plunger to reciprocate. The reciprocating motion is converted into a rotational motion of the motor shaft by the swash plate. In case of inline piston, and by providing a bend in the shaft of the cylinder block in case of bend axis type of the piston motors. The explode view of the inline piston motor as shown in figure, dear students. Hope you understand so how it works. Dear students, what we can see, these images are indicating the hydraulic motors. What we can see, the above images are indicating the inline piston motors, and what we can see, this is the rotary piston motors from the below figures. Now let us discuss the pneumatic motors or air motors, van motors, piston type motors, and turbine motors, and georotors. These are the air type of motors are pneumatic motors. Dear students, let us discuss the van type of motors. In the slot, there are generally 3 to 10 vans. To enable the vans to come out of the slots, they are designed with a compressing spring or pressure air. Per motors equipped with an even number of vans, connecting pin links dramatically opposite vans so that as the bore surface pushes one van in, the pin pushes the other van. But leakage probability will be there when the van tip wear out. The van motors run at 100 to 25,000 rpm. Uh, Normally, the rotary van motors are normally used in applications requiring low to medium power outputs. Simple and compact van motors most often drive portable power tools, but certainly are used in a host of mixing, driving, turning, and pulling the applications as well. The vans are uh, biased to seal against the housing interior wall by spring, cam action, or air pressure, depending on the design. The centrifugal force that develops when the rotor turns aids this sealing action. The torque develops from the pressure acting on one side of the vans. The torque at the output shaft is proportional to the exposed van area. The pressure and the movement arm, which means the radius of the rotor center line to the center of the exposed van through which the pressure acts. As we can see, this is the van type of pneumatic motor. Now let us discuss the piston type of pneumatic motor. The piston air motors are used in applications requiring a high power and high starting torque and accurate speed control at low speeds. They have either 2, 3, 4, 5, or 6 cylinders arranged either axially or radially within the housing. The output torque is developed by the pressure acting on the pistons that reciprocates within the cylinders. The power developed by the piston motors depending on the inlet pressure, the number of pistons and piston area, piston stroke, and speed. The radial and axial piston motors have one significant limitations. They are internally lubricated, so oil and grease supplies must be checked periodically and replenished. The radial piston motors, the feature robust oil lubricated construction and are well suited to continuous operations. They have the highest starting torque of any air motors and are particularly beneficial for applications involving a high starting loads. So overlapping power impulses provide the smooth torque in both the forward and reverse directions. The sizes range to about 35 HP for speeds up to 4500 rpm. And axial piston motors are more compact than radial piston motors, making them ideal for mounting in close quarters. Their design is more complex and costly than van motors, and they are grease lubricated. However, the axial piston motors run smoother and deliver the maximum power at much lower speeds than van motors can. Axial piston motors also tolerate the high ambient temperatures. A maximum sizes are about 3 to 1 by 2 HP. As we can see the axial piston motors, dear students. So this is the exhaust port, this is the transport port, and so reed valve, this is an reed valve, this is the air flow from, this is the air flow or air inlet. So this is an uh, this is the enclosed vacuum denoted by this is the this is called this denoted in blue in color. This is the vacuum enclosed vacuum chamber. Now let us discuss the turbine motors. It converts the low velocity high pressure air to high velocity low pressure air by passing it through a metering nozzles. The major advantage of this is that there is no rubbing or sliding contact between the rotating parts and the body cavity. This reduces the wear and lubricated air is not required to seal and lubricate a lubricant problem. The application is advisable only in a low ambient temperature because of the lubricant problems. There are high speed low torque motor for same volume of air than piston man type. As we can see, this is the uh, turbine pneumatic motors. This is the air inlet. Through this the air is entered into the turbine. So once the turbine start rotating clockwise direction with help of the bearings, so the pressurized air is come out of the other port, which is out, outlet port, air outlet port. Yes sir. G-rotor, dear students, these D-rotor types motors are mostly used for the low RPM pressure applications such as 20 to 30 RPMs just. Hence they may not be suitable for the high torque applications. As you can see, this is the kind of G-rotors which is having a very small gear inside the chamber. So the, as you can see, the internal teeth of the gear, this is the air inlet, and this is the air outlet. So this is the input shaft drive gear mechanism. So advantages of air motors: variable speed, easy to use, low weight, expansive uh, inexpansive, stall damage, protect for the conditions where the motor works in stall conditions, run tools, which means especially in overload conditions, explosion proof. So instantaneously reverses except when specifically noted. And applications of the air motors: construction engineering, hand tools, mining engineering, woodwork builds, mechanical applications like hammering, riveting, and drilling. Indoor manufacturing plants, mobile portable equipments at sea or on land, on non-electrical for hazardous locations, emergency backup to the electric motors for the critical operations, outdoor, remote, and underwater equipments. Hope you understand, dear students. Now we will stop this session. We will continue the next session in. Uh, we will continue the next topics in the next session. Thank you very much.